So I've got RhinoCAD open and I can click on the Tools browser, 3D Digitizer, and connect. The brand I'm using is a Microscribe. There's Romer and Faro, which are two other competing brands. Not what I bought, but that's okay. And it says up in the top corner, connecting arms. Oh, I must have clicked on Faro accidentally. I did. Microscribe. Device could not be initialized. I may not have it plugged in. 1 second. Alright, we're back. So I didn't have the USB drive connecting the Microscribe to my laptop plugged in, so we should be good now. So please confirm the tip of the Microscribe is in the default position, so we are. And what it asks me to do is to provide it with information. So it wants to know the origin. This may be tough to do with the camera in my hand, so I'll put it down. And I use this remote device that comes with it. And what I have to do is tell it where its coordinates are. So I always clamp the device to the bench. And first I have to give it its x-axis, so I use this soft jaw as its x-axis, and then I come over and I touch off the back side and I give it its y-axis. So now it knows where the part is, so I can type in 0, 0, enter, and then I can start selecting devices. So this is where it gets pretty tricky. So this is where the Microscribe really starts to shine. Basically what it ends up doing is it works as the mouse. So instead of me having to move around and measure with a caliper to get dimensions, I use the tip of the Microscribe and I move it around and I touch the part in multiple locations, and then the actual design starts to come up in CAD. So I'll highlight on the top view and I'll set the camera down, and hopefully some of this will show up for you guys because I need both hands to do this. So I select a circle by 3 points because that allows me to accurately figure out where the location of this linkage's geometry is. And you can see I move it around the crosshairs right now. That's with the mouse. Now if I pick up the Microscribe from its home position, and you can see a new mouse appears on the screen. So that's me physically moving in 3D what I'm going to create or what I'm going to trace. So the bearing is still pressed in, which is good because that tells me where it has to end up, and it also allows me a flat surface to rest the tip of the Microscribe against. So what I'm going to end up doing is touching off the surface of these bearings in 3 places, and within all of 20 seconds or less, I now have the dimensions for this linkage. So those 3 circles on the screen are going to be accurate within 1/1000th of an inch or better of this linkage. So you can already just get a visual right off the bat of what you're looking at with that linkage. And being able to do that so quickly enables me to figure out how I'm going to draw this in CAD and how I'm going to measure around the part and figure out what's going on in order to recreate something that isn't available anymore because this is from the 80s. So what I can do now is click on the dimension button and diameter and click on each one of these circles and get an idea for what this size is. So right off the bat, if I zoom out, my Microscribe is telling me that one is 1.07, 1.06, 1.07. This is a Japanese bike linkage. I've always just worked in Imperial, so that's probably something I should work on. 1.06 times 25.4. Oh, might help if I entered that incorrectly. 1.06 times 25.4 is 26.9, so that's 27 millimeters. Is pretty much a guarantee. If I take my digital caliper, let me see if I can get this set up so that you guys can see what's going on. And there's some decent lighting. That's upside down. So the microscribe read 27 or 26.9, and my digital caliper is reading 26.9, 27. So that's very, very accurate. That's within a very small tolerance. So this is where it gets awesome. What I can end up doing is actually taking a bore gauge to be really accurate and measure and snap this to the inside and then measure with my caliper to confirm that what I've read on the microscribe is as accurate as what it should be. So I don't have a camera on my, or a screen on my camera, so it's hard for me to know if you see exactly what I see. I'll try to kind of move the camera around so hopefully you can. But I've just used this snap gauge, and right off the bat the snap gauge is reading, or bore gauge some people call them, 26.94. So this measuring arm that I'm using, the microscribe, measured 26.9, and I got 26.94 on the snap gauge. So I'm in very, very, very close range, very, very accurate range. So what I'm able to do now is come back to the screen, and I'll delete these dimensions just so they're out of the way, and I'll start drawing up a CAD model based on some other dimensions. So I'll use the microscribe to measure the outside diameter, and outside diameter, just so that I can try to keep the overall size of this linkage as close to the same as possible, and take you guys along for the ride. So stay tuned.